Okay, continuing to review reactions of alcohols, starting from the same molecule. Let's treat it now with a different set of reagents. So first, we're going to be doing POCl3 with pyridine. Then we're going to treat it with, say, hydroxide, sodium hydroxide. Third, I'm going to do metachloropurbenzoic acid. And lastly, we're going to use a thiol here. Okay, so let's see what happens after all this transformation. The first step here is transforming the OH, making a chloride. And that reaction happens with inversion of configuration. So reaction 1, the product is the following. So I'm going to do chloride here. That. Okay. So second reaction, we have already talked about this type of reagent. It's a strong base, strong nucleophile. My alkyl halide is secondary, right? So the preferred product is going to be the ethyl product. And that we have a hydrogen that is anti-periplanar to the leaving group. So the E2 can happen to this side and give us the more substituted alkene. So let's do that. So after reaction 2, I am going to have the following alkene. So we have done that in different ways in other problems. Okay, now that I have that alkene, I see that reagent, metachloropurbenzoic acid. This time, just let's remember what is that reagent. So let's do benzoic acid, similar to benzoic acid, but now you will have an extra oxygen. That is a per acid. And in the meta position, you have a chlorine. That's that. So, but the general formula, let's say that you have a per acid will be CO3H. Or you can also draw this way. Several ways. So that is a per acid. And what it does is we're going to form an epoxide here, the alkene. So we're going to add that oxygen. So reaction 3, we're going to make that. And so here you're going to make your epoxide. And that's that. And if we had that in water, then we will have the nucleophilic attack of water and make a diol, an anti-diol. But this time we don't have that. We instead have a thiol. So let's draw the reaction. What happens when I treat that epoxide? And it also says acidic conditions. So reaction 4 says that you're using this thiol, and that is under acidic conditions. So under acidic conditions, we're going to protonate the epoxide. Remember that we can have the epoxide also this and dashes, and that will be on wedge. I'm drawing just one of the possible. Under acidic conditions, you will have this intermediate, and then you will have the nucleophilic attack by what? By the thiol. And the nucleophilic attack will happen at the more substituted carbon. And opposite to that, so it's going to go here, and the epoxide is going to open. So the final product for that, and let's see if I have room for this, I'm going to have to make it smaller. So this will open up, and I will have an OH here, and here I will have, say that it went I'm gonna erase this because I don't have enough room. So from that drawing, I'm gonna modify the drawing on the top. Well, that's not a good idea because I want to keep my molecule here in mind, but I'm gonna draw it on the top. I don't want to keep the whole sequence on the board. That's what I want to do. That's why I'm redrawing it. So my initial molecule is this, and then I'm gonna draw an arrow from here to the final product. What I'm doing is I am modifying this molecule, and if you do that attack by the thiol, then you will have here, say that let's put that on wedge now because I said the attack is on the back. By that you can have the two enantiomers, that two configurations at the center. So you had attack with the S, with the sulfur, and you have that. And of course, initially you will have an extra product here, and that you need to undergo a proton transfer in the final product will be a thioether at this position. Now, if you have the epoxide form here, the two dashes, and then you will have the opposite configuration here, you will have the other product, which will have this on dash and this inverted, so the enantiomer to that. So doing a little bit of a recap, this was my initial molecules. Oh no, that arrow wasn't right because that came from this. So my initial molecule is the one on the top. That happens because I had to redraw, right? So my initial reaction was transforming the OH into chlorine here. So I made an alkyl chloride. Second step, we did an alkene that was an E2 elimination that happened into that side, forming this is my side Ceph product, alkene. And then in the third step, we use a per acid, metachloroperbenzoic acid. We form the epoxide here by inserting at the double bond. And again, remember that you can have that the opposite, say dashes here and wedge here. And lastly, we open the epoxide with a nucleophilic attack. So the protonated epoxide is this, acid conditions, and you had the attack at the more substituted. So that's your final product after proton transfer. You need to remove the at. You will have a thioether in that position.